Okay, in this video we're going to continue our study of three-dimensional figures and specifically figures that involve circles. And the next one that we're going to study is a cone. Okay, so this one is where we have a figure where its base is a circle and the circumference of the circle is then connected completely to a single point which we call the vertex. Okay. Then, as with pyramids, we have a slant height. We denote that with an L. And we have a height which is directly from the vertex, or that I should say that joins the vertex with the center of the circle. And then we have a radius, of course. And then we can compute, again, volume is given by 1/3 pi r squared h. Very similar to the pyramid, but instead the base is now a circle instead of the base being a polygon. Okay, and then the next thing that we're going to discuss is the formula for the lateral area. So the lateral area, again, would be this side of the cone. Okay, and we're going to discuss how to make that. And then to find the total surface area, again, you would have to add on extra pi r squared to the quantity that we're going to find right now. So when we go ahead and find this, I first want to imagine that you identify a point on their circumference, and we cut along this edge from this point. I don't know. Let's call it x. To a vertex, and we'll call this y. So we're going to cut along this edge, and so we have something that looks like, okay, here's x, here is y. Okay, and then I cut that, so that distance that I cut, that is the slant height, right? So that's L. And I go ahead and then I unwrap the whole thing, and I would make a complete circle, but it would appear to me as an arc. And then I would also have another point over here, and this would actually be the same thing as x. So this would also be x, but for our purposes, just so we know that they're different, I'm going to use a prime. Okay, and this would just be that when we fold it back up, I would connect x and x prime together. They would be the same point. Okay, but now, so I know that this is L, but then my question is, what is this distance along this bottom here? Well, that is actually going to be the circumference of the circle, right? So that distance is 2 pi r. Okay, so now this would actually form a sector of a circle as well. So I know that the whole circle, so I'm just going to make a note here, whole circle, if I were to complete this entire thing, it would be 2 pi, and then the radius in this case is L, because this is my vertex and all these points are the same distance from this vertex. So it would be 2 pi L. Okay, but now I only want a sector of that, so my sector is, well, the total is 2 pi L, and this portion that I have is given by 2 pi r. Again, just this measure of this arc. So 2 pi r. So this reduces to r over L. Okay, and then as before, when we were determining the area of a sector, so the lateral area, I would need to take the proportion or the angle measure of this sector. So I would take r divided by L and then multiply that times the whole circle. So this says I have, of the whole circle, which is 2 pi L, I have r over L of that. And, oh, sorry, L, let's try that again. That's not the area, that's the circumference. This is pi r L. And just kidding again, and it's actually just pi L squared. Okay, pi L squared. And so after I do the arithmetic here, this would end up being pi R L. That's the formula that I was trying to get to. Okay, so again, that would just be how we determine the lateral area. And so from now on, if you just want to jump straight to this, feel free to. Okay, and then my question here is it possible for the slant height of a cone to be smaller than the cone's radius? Well, again, one of the strategies when we're dealing with three-dimensional figures is trying to visualize them in 2 dimensions. So if I look at this diagram here, so my slant height is going to be this diagonal distance here, and r is here and height is here. So really what I'm seeing is a right triangle. And so this would be perpendicular, this is the radius, this is the slant height, and this is the height of the cone. So if I have a right triangle, I know that I have the relationship L squared is equal to R squared plus H squared. Okay, but I think this answers our question without going too much further, and I could almost have stopped at this diagram. So is it possible for the slant height to be smaller than the cone's radius? Well, not really, right? Because in a right triangle, the hypotenuse is always the longest side. So as the hypotenuse is L, that always has to be the biggest. Okay? And we're going to go ahead and work through some examples. And so the first one is the cone has a lateral surface area of 54 pi whatever unit we have. So lateral area is equal to 54 pi, which I also know is, as we just talked about, pi RL, and I know that the radius is equal to 6, so I go ahead and substitute that in here, and so I have 54 pi is equal to pi times 6 times L, so that means 9 is equal to the slant height. Okay, and then it said find the slant height, the height, and the volume of the cone. So we found the height, or the slant height, so now I want to find the height of the cone. So in my previous diagram that I just drew on the last slide, I know that if this is the slant height, that's 9, the radius is 6. I want to determine the height. Well, that's given by the Pythagorean Theorem, so height is going to equal the square root of 9 squared minus 6 squared. And so this ends up being square root of 45, or we can reduce this to 3 square root 5. Okay. Again, make sure that you pause the videos and check these calculations on your own. And then lastly, it says, so I got the slant height, I got the height, now I need the volume. So volume is 1/3 pi r squared h, and so this is going to be 1/3 pi times, the radius is 6 squared, times the height, which we said was 3 square root 5. Okay, and when all is said and done, I get 36 pi square root 5 for the volume of the cone. Alright, and continuing right on, again, pause if you need to. Example 2 says 1/3 of a circle of radius 9 is rolled, with a D, up to form a cone. Determine the lateral surface area and volume of the cone. So the idea is I have a circle. Okay, here's my circle. But I only consider 1/3 of it. So if this is my center point, I take 1/3 of it, which looks maybe about that sector-ish. Okay, again, this is just a sketch. And I know the radius is 9. Okay, this sounds really familiar. This is similar to what we did when we were determining the formula for the lateral surface area. So I know that this entire circumference, well, okay, let's pause. Let's actually go ahead and now make this into a cone. So I identify this point as that one, and then I form the cone. Okay, circle-ish. And so what I know on here is that the slant height is 9, and I need to determine the lateral surface area. Okay, here's a picture, and wait, this distance here, this would be this distance would be 1/3 of the circle, and this distance would be 1/3 of the circumference, and the circumference here would be 2 pi times 9, so that would be equal to just 6 pi. So I know that the entire distance around here, the circumference of this circle, is 6 pi. So I know circumference is 6 pi. Okay, but now I also know that circumference should be 2 pi r, so this is equal to 6 pi. So that tells me that radius of this new circle is just 3 whatever units we're in. Okay, so that's great, and that's actually enough to let me determine the lateral area, the lateral surface area. So the lateral area, surface area is equal to pi rl. Okay, and pi, I know that the radius is 3, lateral, or the slant height is 9, so this is just 27 pi. Alright, and now for the volume, I need one more dimension. I need this height dimension. So again, I can use the Pythagorean Theorem to determine that quantity. So again, I'm thinking that, okay, slant height is 9, radius is 3, and I want to determine height, that's an h. So height is going to equal the square root of 9 squared minus 3 squared. So this is going to be the square root of 72. Okay, and after simplification, that is just 6 square root 2. So then this allows me to determine the volume to be 1/3 pi r squared h, and 1/3 pi radius is 3 squared, height is 6 square root 2. Okay, and so after simplification, I got 18 pi square root 2 as the volume for this particular cone. Okay, and in the next video we'll do one more example involving the frustum of a cone.